Welcome. I'm going to go over solutions for the problem set assigned for Part D of Section 6.1. So question 8 in the exercises within the Topic 6 chapter on page 211. Number 8 is asking about a catalyst. And one thing you have to remember with the catalyst is it decreases the activation energy. So that means the hill gets lower for both the forward and the reverse reaction. So when I look at these, I'm looking for the correct statement. A says it increases the rate of the forward reaction only. That's not true. B says it increases the rate of the forward and the backward reactions. That is true. It makes the reaction easier for both directions, so both forward and backward reactions will increase. Increases the yield of product. Nope, has no effect on the product or the equilibrium. And D, increases the activation energy. Nope, it decreases the activation energy. So the only true choice here is B. It increases the rate of both forward and reverse reactions by lowering the energy needed to get to that middle ground, that middle hill where the magic happens. Number 9, which statements are correct for the effects of catalyst and temperature? Well, catalyst, we know that it's going to decrease the activation energy. It's not going to affect the collisions. So the only one on here that fits for adding a catalyst is with part B here, activation energy decreases, and increasing temperature will increase frequency collision. It won't affect the activation energy. So B again is my only one where I have true statements for both the catalyst and the temp change. Number 10, in the reaction between marble, calcium carbonate, and hydrochloric acid, which set of conditions would give the highest rate of reaction? So I have my choice between marble chips and marble powder. So powder is going to be better, it's going to have more surface area. And then I have my choice in 1 molar or 0.1 molar HCl. So the more concentrated HCl. So the best combination of those would be B, the marble powder, and the 1 molar HCl. Number 11, a sugar cube cannot be ignited with the match, but a sugar cube coated in ashes will ignite. Suggest a reason for this observation. The ashes apparently, I'm not quite showing up there, so let me try that again. The ashes must contain some kind of catalyst. Something in the ash chemically serves as a catalyst for this reaction. Okay, looking at the practice questions over on page 212. Question 1 says you start out with decomposition of hydrogen peroxide, and it's a 1 molar solution. And I see the red line there, or graph X. And they want to know, how do you come up with Y? What would have happened? Well, two things that occurred is it's a slower rate, a slower reaction, but there's also more product. So I need to find a change in condition that would produce both of these effects. And as I look, adding water would slow the reaction, but it wouldn't give me more product. Using a different catalyst could slow the reaction, but again wouldn't change the product. Lowering the temperature would slow the reaction, but not change the product. The only one that would both slow the reaction and increase product would be B. I add some more hydrogen peroxide, but because it's a weaker concentration, it dilutes my solution, so my reaction is slower overall with more product being produced. Number 2, which changes increase the rate of reaction below. And as you look at this, increase of pressure, increase of temperature, removal of HCl, they all sound good, except you have to keep in mind that we're talking about rate here and not equilibrium. So as I look at number 1, increase of pressure, because I've got 2 gases on the reactant side, 2 moles of gas, and I'm only making 1 mole of gas on the product side, increase of pressure will increase the collisions more on the reactant side and will increase the rate. Increase of temperature always increases rate. And then removal of HCl, even though that'll cause more product to be made, it will not increase rate. So only 1 and 2 will actually increase the rate. Increasing pressure because the collisions pick up on the reactant side, and increase the temperature because collisions will increase as well. Number 4, powdered manganese oxide increases the rate of decomposition reaction. So which statement about MnO2 are true? The rate is independent of the particle size of MnO2. That's not true. More surface area always increases the rate. Number 2, MnO2 provides an alternative reaction pathway for the decomposition with a lower activation energy. That is likely true because that's going to affect the catalyst or act as a catalyst. And then statement 3 says all the MnO2 is present after the decomposition. So 2 and 3 are describing a catalyst, which is what MnO2 appears to be here. So I would go with C, 2 and 3 only. And then number 6, a student measures the rate of reaction by timing the appearance of a precipitate that forms in an aqueous solution. Which of the following would increase the time required for it to form? So this is increasing time is slowing the reaction. So A, raising temperature, that's going to decrease time, not increase it. Adding a catalyst will also decrease time. Diluting the solution, this will slow it down. Stirring the reaction, nope, that speeds it up. So C is the only one that will slow the reaction rate. Number 11, it's found in the reaction that an increase in temperature increases the rate. Which statements below is the main reason for this? You notice the emphasis on main. So A, molecules collide more frequently. That's certainly true. But B, the proportion of molecules with energy greater than the activation energy increases. This is a bigger reason for it, because more collisions won't increase your rate if they don't have at least the minimum amount of energy. C and D don't affect it. The pressure exerted by molecules increases. Proportion of molecules with correct collision geometry. Neither of those is going to be a factor in increasing the rate with the temperature increase. So B is going to be the main reason for that increase. And then number 12, zinc metal reacts with copper sulfate, which will increase the rate, increasing the concentration of the aqueous solution. Yep. Decreasing the size of the zinc pieces. Yep, that increases surface area. Carrying out at a higher temperature. Yep, all 3 of these will increase your rate.